All right, so today what we're going to do is we're going to continue our look at areas of shapes, but this time we're going to look at what are called composite shapes, whatever you prefer the pronunciation, I don't care. In other words, these are shapes that are made up of other shapes, okay? So these are shapes that are made up of other shapes, either put together. So sometimes you're going to be finding a bunch of areas and then adding them all up, or taken away. So for example, you may have a shape that has a triangle cut out of it, right? So you have to think of, what I need to think of is, can I make this up of a bunch of shapes that I added together, or were a bunch of pieces cut away, etc. Now, they will only use the types of shapes that we already have talked about the formulas for. So squares, rectangles, triangles. What else?
Diamonds.
Did we talk about those?
Rhombus.
Parallelograms, I think is what you were looking for. Okay, so that's, guys, come on. There's all the shapes that we've talked about and we've used formulas for that were in our notes from before. But they've been pushed, they've just been pushed over. Okay, so what we want to do first then is divide into the smallest number of shapes that you can. But remember, we only want to divide it into shapes that we know formulas for. So if you don't divide it into some shape that you don't have a formula for, that won't do you any good. So for example, can I cut it into a square and a rectangle? Can I cut it into a rectangle and a triangle put together? All right? So we just need to find out. And we always want to make sure it's the smallest number of shapes that is possible. You don't want to be adding 16 things together when you can add 2 together. All right? And you need to also make sure that the shapes you're cutting it into, you have the measurements for. I can cut it into 15 rectangles if I want to, but if I don't know how big one of the rectangles is, it doesn't do me any good, does it? So watch the measurements. Oftentimes the measurements will tell you how to cut it up. All right? Then, find the area of each shape. So you're just going to draw some new lines to cut it up into spaces, and then you're going to find the areas of all those new shapes you've just created. Now I'm going to continue the notes here, so that's why I'm drawing a solid line instead of a dotted line. You can just go down on your page, but I'm out of page. Step 3, add or subtract the areas. Sometimes you're going to be finding the area of a cutout space. In that case, you would subtract it. But if you're just dividing it up into lots of pieces and then you find the area of each piece, then you'll add it. So be aware that you need to either add or subtract. Don't always think you're going to be adding these things. Okay? All right. Sometimes you might have to find the area of a missing piece in order to be able to find the area of the rest of the shape. So keep that in mind. So we may have to complete a shape for that to happen. So what we're going to do is we're going to go to the Snowflake book, and because you really need to see these. It's a very visual kind of thing. But think about what it is we're trying to do. We're trying to turn shapes we don't know we don't have a formula into shapes we do have a formula for. Okay? So let's go there. All right. So here we go. So here's a shape. Find the pink shaded area. So you see that the pink shaded area is a rectangle with a hole in it, right? So what we need to do is we need to find the area of the whole rectangle on the outside. And since this part is cut out, I'll find that area and then we'll do what? Subtract it. It's very straightforward, yeah? So the area of the outside rectangle is 8 meters by 9 meters. So 8 meters times 9 meters, because the formula is just for a rectangle is length times width, gives me an area of 72 what? Meters squared. Excellent. Now we'll find the area of the shape inside, and that's 6 meters by 3 meters, which is 18 meters squared. And then I'm simply going to do some subtraction. So what is 72 minus 18 getting me, guys? 54 meters squared. And don't forget your units. Excellent. All right. So in this case, we had a big hole in it, so we knew we had to find the whole area and then subtract out that hole. Okay. Now, that one was fairly straightforward. We just had 2 shapes to deal with, and we were done. But you can have more shapes and more pieces. But think about how you can do it in the easiest way possible. Now, if you look at the next shape, we could try turning it into a bunch of little shapes, but if you look at it in reality, what we have here is a what? A rectangle, right? With a what? A triangle cut out of it, and a what? And another rectangle cut out of it, right? So sometimes you'll be drawing lines on the outside to complete a shape. But then you have to take out those areas that don't really exist. So if I know that this is 8 on this side and this is 12, that means that 8 meters, centimeters in this case, centimeters times 12 centimeters gives me what, guys? Come on, you're the ones with calculators. You're going to sit right in front of you and not going to tell me out. 96 meters squared. Good. Centimeters. I'm sorry. I'm only going to deal in meters today. Now I'm going to find this area of a triangle. That's 1/2 times 6 centimeters times 4 centimeters, because it's base times height. Because it's a triangle. The formula for a triangle is 1/2 times base times height. Okay? So 6 times 4 is 24, and half of that is 12 centimeters. Now again, remember, we got to take that out, right? So let's put a minus there to remind us that we're taking that out. And this shape in the bottom is a rectangle. So that's 2 centimeters times 8 centimeters, which is 16 centimeters squared. And we're taking that out. So we're going to do 96 minus 12, which gives me
84.
And minus 16 more is, pardon? 68 what? Centimeters squared. All right? So sometimes you'll have to complete the shape and then subtract out the pieces that you don't need. Okay? Make it as simple as possible. If you can turn it into a rectangle, that's easy. If you can turn it into 3 triangles, a rectangle, and a square, right? So try to make it as easy on yourself as you can. Okay? All right. Let's look at some more and see what we got. So they did all the calculations. They did it all in one line. I discourage that, but oh well. All right. So doesn't matter. What do all these lines mean on this shape? They're all the same as what? 2. So they're 2 meters, right? So how could I cut this up in a way that I would know all the measurements? Well, how would I cut it up? Well, look what happens if you do that. We just turned it into a what? A rectangle, and that's 3 sides of the 3 2s, which is 6, and then cut out each one of these, which is a square with sides of length 2, right? So don't try to get carried away. So some of you might have wanted to try to do this little square, this little square, this little square, this little square, this is a rectangle, this is a rectangle, but you couldn't do that because you wouldn't know the measurement in there, right? Now you could, because this is 2 and this is 2, so that would make that 5, but it just makes it a lot harder. There's a lot more pieces there, right? So see if you try to turn it into a bigger shape, and then you can just subtract out the cutouts. Does that make more sense than all those little tiny pieces?
But you have to find the area.
Right. So find the area of the rectangle, which is just 7 meters times 6 meters, because there's 3 lengths of 2, which makes, right? And then find the area of the 2 squares and subtract those away. Okay? Look at this one. This is a rectangle and a triangle. No measuring around those. You're just going to find the area of each one and do what to it? Add them together. Good. Okay. Here we have some cutouts. So find the area of the outside, the area of the inside, and subtract them. Right? Then you're going to have some where they're just going to give you a description. So if you think about it, and it says, find the cost covering the path of slate at $32 per meter squared. So remember that. $32 per meter squared. 72 meters squared times $32 over meters squared, because you need those units to disappear. Remember, make sure you that you put them in the right spot. Okay. All right. And I think all of the rest of them should be pretty straightforward. More of that. Okay. So, your work on page 246, exercise 11E. So 11E on page 246. Okay? If you don't finish it today, you'd have homework. You have to do it for homework. Yes.
Wait, it's 2 pages. 3.
Okay? Go.